Sorry, really sorry, everyone. I had some technical issues and I have to rush to the student office to record the session. Um, I hope everyone is still here with me. So I just wanted to ask two questions. So is my screen visible and am I audible?
Yes, sir. Your screen is visible. You are audible. We can even view you. No problem.
Yeah, sure. Thank you so much, Nikhil. Jocelyn, I am also sorry for like technical difficulties. I couldn't arrange the session on time. But I make the session is recording right now, and I will make sure that this recording will be uploaded as soon as possible. And in addition to that, I have also provided my contact details in the mail through the mail and through the Google groups. So always feel free to post any doubts that you want till the exam is happening. So this is this. I mean, yesterday I had the for those who got the mail pretty late. I think some people got the mail pretty late. So yesterday also I had a session where we discussed about week 12 contents and some of the problems from week 12. So today is the kind of the last session of this week. So this is pretty much a course recap of whatever we have learned for the past 12 weeks or so. So initial plan is this. So I'll just go over all the contents, go over a brief recap of whatever we have learned for the past 12 weeks, and I'll discuss key problems. I mean, problems that I think that many people found difficult to address or answer. So we'll go over those three problems. I've just curated a very short list of problems, 10, 12 problems. I hope that will be beneficial in learning. So without wasting time, I'll just get started. Before that, I'll just also check if I have yeah, its session is recording as well. It's fine. So yeah, I'll get started right away. So week 1 to week 12, there was a very constant flow from one part of understanding one part of science to another. But week 1 and 2 majorly started with understanding first of all what is science and what is logic. So in the initial weeks, we found out that science is studying science or doing research in science basically means that we have to find things that no one knows. So through historical studies and historical relevance, we have found the answers for some things which might hold true for now, but there are many questions for to which we do not know the answers for. For that, we need to find answers, and for that, we use science as a medium, and we use scientific research as a medium. And while addressing scientific research, we also use truth, the concept of truth, and we also come to know that truth has various facets or properties. Some of them being that it's absolute. I mean, it's not absolute. It's unique. Truth is always unique, and truth is not always absolute. There is no absolute truth. Truth is always relative. It keeps changing from one form to another. Based on whatever experimental advances that we have, we tend to find newer truth every day. And in the initial weeks of week 1, we came to study about objective reality versus subjective reality. So what is objective thinking and subjective thinking? So objective thinking is straightforward thinking, which is pretty much a little bit slow. Okay, yeah, sure, sorry, yeah. I think I'm also in uh, kind of a rush due to the wasted 45 minutes. But it's fine. I will also extend the session to 1:30, 1:45 if you people are okay with that as well. Yes. So in initial weeks, week 1 and week 2, we saw more about objective thinking and subjective thinking. So objective thinking was pretty much straightforward, and it was the objective thinking was mostly encouraged by scientists, and in the modern scientific realm, objective thinking is highly encouraged among scientists to find answers to problems. And why so is because objective thinking is a form of thinking and answering which is purely based on facts. So the starting point of this objective thinking is collective experience, and this collective experience does not include feelings. So objective thinking involves only analyzing and studying facts and getting back with results based on those facts. And sometime most of the time objective thinking involves collection of data and organizing the data and then studying the patterns in that organized data. Whereas on the other side, we have subjective thinking, where we have kind of opinions or biases towards certain things, and whatever answers we have are mostly based on those biased thinking. And subjective thinking nowadays in scientific realm is not encouraged. And in future weeks, we also saw that how there is a mix of objective and subjective thinking, and how there was a rise of certain disciplines such as positivism and so on and so forth. And in the later parts of week one, we also saw about materialism versus idealism, and mostly materialism and idealism are just subforms of objective and subjective thinking. So basically, the main properties of materialism is that materialists consider that matter is primary. Whatever is there in the world, whatever is there in the universe is based on matter, and everything can be studied. Everything which is existing is something which belongs to something which can be studied. And idealism is just the opposite of that. There are some idealists believe that there is some part in the universe, some forms in the universe which cannot be studied, which is supra material in nature, which is like above materialistic things, like ghosts or phantom things, God or something like that. So idealists believe that there is some things which cannot be always studied. And later we also came to know about causality. Causality is nothing but uh, there is a relationship between things happening in nature. So if a thing happens, there are some positive effects to it, and depending on the direction of relationship and the extent of the and the influence one variable has on the other, one thing can cause and a cause can lead to an effect. So that's basically causality. And in week two, we jump to logical reasoning and the categories of logical reasoning. So monism is actually not in the material per se, but monism is a so in addition to materialism and idealism, there is an additional two ways of thinking called dualism and monism. So those are just those are combinations of materialism and idealism, but in different weightages.
Okay.
Yes. So in second week, we also jumped to different kinds of logical reasoning. We saw more about inductive logic, deductive logic, and syllogistic logic as well. Syllogistic logic can most probably be defined through Venn diagrams, where one thing causes the other, and another thing causes another thing, and so the relationship can be built in form of Venn diagrams, and the final relationship can be explained through this Venn diagrams. And even in deductive logic, we came across the concepts of modus ponens and modus tollens. So, modus ponens, can anyone explain what modus ponens and modus tollens is? Like, if you remember from week two's lectures. It's okay, it's okay. Uh, there are, we already saw about causality. So, there are two things A. If A causes B, let's just assume that A causes B. So, if A is there, then B should also happen. That form of deductive logic is called modus ponens. Modus ponens. And in modus tollens, if there is a A, there is a B, then if B is not there, then A should also be not there. Then that form of deductive logic is called as modus tollens. So this is what we briefly went through in week 1 and 2, mainly highly focusing on science and logic. And week 3 and week 4, week 3 and week 4, we basically went through historical perspective on early materialism, and how materialistic perspectives came into place, and how there was certain concepts which were not entirely materialistic in perspective, but that also had idealistic shades to it, such as the idea of empiricism. So empiricism basically means that whatever we have, whatever idea or knowledge we have, that is based on previous experience, and as a result, whatever we haven't experienced, we need not study about that. So that was the idea of empiricism. And empiricism was the key pillar of scientific research for a very long time until certain people came, like Galileo and Francis Bacon, and then they kind of shaped the scientific realm into thinking towards more materialistic perspectives instead of considering empiricism as an idea of research. And even after that, even after empiricism and positivism, there was the advent of scientific materialism. So scientific materialism kind of uh, stopped looking at things per se and started with a notion saying that everything changes. Every thing, every identity that exists in the universe is always in change, is always in a state of motion, and what we need to actually study is not the in itself, but the change of the thing from one form to another. That was the main goal of scientific materialism. And towards the week of end of week 4, we also got a introduction into what scientists actually do. How do they ask scientific questions, and what kind of questions do they ask? And while answering the question, what are the steps do they follow while answering the question? And in week 4, we also saw some supplementary concepts such as what is the open question and what is a closed question. So basically, open questions are questions which, when answered, lead to more questions, whereas closed questions are questions when answered does not lead to further questions. And in week 5, we kind of took a deviation from week 4, and then started from the end of week 4 actually, pretty much. We kind of extrapolated from what scientists do to how do scientists form a hypothesis. If you are a scientist, how will you form or propose a hypothesis? And then we also went into some key concepts such as falsifiability and reproducibility. So basically, falsifiability. So Karl Popper came up with this theory of falsifiability, which pretty much said that if there is a scientific hypothesis, it must be falsifiable in nature. It may not be falsifiable in the near future, but in the distant future, with the advancement of science and technology, and with the advent of better machines, every theory or every hypothesis must be falsifiable in nature. There must be some falsifiable criteria for a hypothesis to hold true for a certain amount of time. And then towards the end of the week 5's lectures, we took a look into some of the scientific measurement tools such as mean, standard deviation, and variance. And this kind of scientific measurement led us into the introduction of week 6, which focused on the central limit theorem. So basically, the central limit theorem basically said that if we have a random distribution as in which is like not a part of like a Gaussian distribution. This is a Gaussian distribution, a normal distribution, and the distribution behind the shaded distribution is a random distribution. So he was the central limit theorem basically said this. So let's just have a random distribution. So if we take random samples from the random samples from the distribution, and then plot the mean and standard deviation of all of them, then the mean of all the samples will form a normal distribution, and that having a mean of the same mean of the sample population, the sample mean will have the same mean as the population mean, and the standard deviation of the Gaussian normal distribution will have a standard deviation of its own, which will be somewhat divided by the standard deviation of the population divided by the square root of the number of samples. So that's what central limit theorem basically explained. And towards the fag end of the central limit theorem, we also got an introduction into error bars, and then we also got an introduction into standard error. And then towards the end of the week's lectures, we kind of got some important values to remember for standard errors. Basically, how much standard deviations of a distribution will correspond to how much confidence of population. And basically, this values might be important for you people in case you are attending the exam. Basically, you might need to remember 90% for confidence interval, 95%, 99%, and 99.7%. Yes. And after that, we went back into, so in week 5 we focused on forming a hypothesis. In week 7 we kind of focused on testing a hypothesis. using the tools that we already have, such as mean and standard deviation and standard error and error bars. Apart from that, we also got an introduction to measurement of proportion. So, out of measurement of proportion just means how much amount of a population has a distinct proportion in a total amount of population. And then we also got an introduction into box and whisker plots, explaining what is a box and whisker plot, what are the properties of a box and whisker plot, what is basically the interquartile range. Interquartile, so box and whisker plot have three quartile values, especially basically the Q1, Q2, and Q3. The Q2 will almost always be the median of the box plot, and Q1 and Q2 will be Q3 will be the lower and upper quartile values respectively, and interquartile range will be the difference between Q3 and Q1. And then when you finally plot a box and whisker plot, you'll always get the outliers, and the key rule in box plot is you must always include the outliers for representation, but for calculation you can leave the outlier outside. And we also got in week 7 we also got introduction into propagation of errors. Basically, when we do different kinds of operations such as addition, subtraction, multiplication, or if you doing finding a variable through a function of another variable, how would you propagate the error associated with the certain initial variable, dep- dependent variables, sorry, independent variables. So if we are performing an operation for a dependent variable based on certain independent variables will carry an error. How are we going to combine the independent errors of the independent variables to form the error of the dependent variable? That's what we got to know in the propagation of errors. And then we got to know about additional concepts such as type 1 error and type 2 error in the part of issues in hypothesis testing. And we also got to know about what is confirmation bias in scientific research. So confirmation bias basically means that, so we will have a certain belief, and we would be desiring some outcome. So if we are trying to make our experiment or design our experiment in such a way that we always get the desirable outcome as the answers, then that means we have a confirmation bias. And towards the end of the week 7 lectures, we also got to know what is a single blinded and double blinded study. I think we also had a extensive discussion about single blinded and double blinded study in the previous week. And following that, in week 8 and week 9 was heavily mathematics oriented. We got to do many statistical tests such as Z test, T test, and chi-square test. And there were certain formulae associated with Z test, and T test, and chi-square test, which you people might need to remember as well. And then in week 9, we also got to do some dimensional analysis, and also we also got to do this least square fitting problems, which some of them will be discussing in the uh, problem session as well. And in week 10, we got to know more about theoretical research and scientific writing, basically how to write a scientific paper. And we also got to know more about the theory of knowledge. How do you build a theory, how to test a theory, and after testing a theory, how to build a mathematical model from it, how to compile all those results and write them into a meaningful paper. And week 11 was just a extrapolation of scientific writing. It extended into, it first started with writing a thesis defense, and then after that it extended into scientific communication in general, where we sort of saw some concepts regarding oral presentation and poster presentation. And towards the end of the week 11, we also got to know how to write a project proposal, what are all the properties or what are all the things we need to keep in mind while writing a project proposal. And towards the final week of the lectures, we sort of um, we sort of got some. One second, Karunidhi, I'll just finish this recap, then you can ask it. So, towards the final week of the lectures, which we saw last week, we saw more about research ethics and research types of research misconducts, and then we also saw some cases and scientific misconduct, which kind of led to a final moral of the story or the ultimate goal, which is to propagate and perform science in a good manner, and then make it useful for people. So whatever science we will be doing should be done in a careful manner and should always have a social responsibility. So that's all the doubts. Sorry, that's all the points that I have for the today's session. This is basically the course recap. So whatever key concepts that we observed across 12 weeks. So after this, I'll just be going into some key problems. So before that, if you guys have any doubts, we can discuss for 5-10 minutes. After which I'll jump into the problems. Karthik Karnataki, I think you had a doubt previously. You can ask right now if you want to. I'll leave the room open till 12:15. Till that we can discuss some doubts, and later we can go into the problems.
Sir, just one question in that central limit theorem. You had mentioned various HDs, like one HD is usually 68%, right?
Yes, yes, yes,
1.64, 95%, etc. That
yes.
is okay. Last, the only last point I was not clear. Scientific discovery is 5 HD.
Oh, so yeah. So if theoretical scientists, whenever they want to make sure of if they are discovering something, whatever findings they are finding along with the discovery, whatever data they are collecting along with the discovery, that kind of data should will be taken valid only if they are five standard deviations, only if they are confident of five standard deviations. So that's
Okay.
basically 99.999%.
Okay.
Yeah, so that's
Okay.
basically 1 in 1 million or one in 6 million observations will be erroneous.
Okay, sir. So whenever we are proposing any means a scientist is proposing any theory, he has to be sure to the extent of 5 ± 5
Five set,
sigmas.
yes,
Yeah, yeah.
five sigmas,
And sir, then we also hear about 6 sigma
six
many a
sigma.
time.
Yeah, I
So it
mean,
is +or -6 sigma, kya?
yes,
Means it
yes,
will be 12
yes,
sigmas.
yes.
Okay.
I mean, to be very frank, plus or minus six sigma is almost perfection. So that's why
Yeah.
they all always say six sigma companies and all those stuff.
Yes, yes. Okay, sir.
Yeah, it's like 1 in a trillion or 1 in a 10 power 12 observations would be very erroneous. Six
Okay.
sigmas. Any other doubts that we have? I mean, it's fine. We can also always have doubts at the end of the session as well. So, as I mentioned in the start of the this course recap, I have prepared some problems, and most of the problems, some of the problems are theoretical, and some of the problems are mathematical, like you people requested yesterday. And theoretical problems also, some people face some difficulties in the last session. So, I have gathered some theoretical problems as well. Um, if you have any other doubts and any advanced problems, you can always approach me. But these kind of problem questions or problems is what I feel would you guys would get more in the exams. That's why I kind of grabbed these problems. And you would already notice that most of the problems that I have gathered are from your previous assignments only, and not from any other sources. So I'll kind of get started. So, question: if it is given that if copper is dipped in vinegar, then copper turns green. So they have said that copper dipping in vinegar is kind of a cause, and then copper turning green is an effect. So you have A causing B, and then they are given four options. Out of that, you have to choose which one is a much more valid option. It's a multiple select question. So feel free to answer any question and give a reason for these questions as well. I'll give you 1 to 2 minutes time to answer. Nikhil saying C and D. If copper did not turn green, then copper was not dipped in vinegar. If copper is dipped in vinegar, copper must turn green. Yes, it's kind of correct only, but can you also um, explain why you're getting C and D? Dakshata, you're saying
Yeah.
D. I'll come to that later. Come back to that later.
Okay. So if copper is dipped in vinegar, then copper turns green. Okay. It can be one of the methods of turning it green. You
Yes,
can dip it in vinegar, you can dip it in something else, but
yes,
when you dip it in vinegar, it will surely turn green.
yes,
So, if it is not green, that means surely it is not dipped in vinegar.
yes,
Surely.
yes, yes,
So that's why I said C is one of the option.
yes, yes, yes,
But then if copper is dipped in vinegar, then copper must turn green. That is, in fact, in a way, they have directly given that. Just they have added must. Okay.
yes,
So the statement is the input. Now, why A and B are not there, in my opinion, is copper. If copper is not dipped in vinegar, then copper does not turn green. It's not necessary. If copper is
exactly.
not dipped in vinegar and maybe it is dipped in, let's say, XYZ solution, it may still, that may be a possibility. That's why A is not absolute truth. Then
Yes,
if
yes,
copper is turned green, then it must have been no. It it was dipped in vinegar is one of the possibilities. There can be other solution also XYZ which might have turned it green. That's why A and B are not there, in my opinion.
sure. That's absolutely correct as well. I hope everyone got the answer as well. I'll explain it once again for people who didn't understand. So basically, you address this problem. You find the answers for this problem by using deductive logic. So in deductive logic, we have come across concepts called modus ponens and modus tollens. So in modus ponens, I have told you that if A, there's a situation where A causes B. So if A is there, B should also be there. That is modus ponens. Modus tollens says that providing A causing B, if B is not there, A should also be not there. So that is another form of modus ponens. So these two, modus ponens and modus tollens, are the valid forms of deductive logic, and none of the other reasoning kind of deductive logic reasoning would be valid. Would be a valid logic. So using modus ponens, your option D will be correct, and using modus tollens, your option C will be correct. So once again, so the correct answer will be option C and D. If copper did not turn green, then copper was not turned in vinegar. So it's perfect form of modus tollens. And if copper is dipped in vinegar, then copper must turn green. So it's a perfect form of modus ponens. And with respect to the other two options, copper is not dipped in vinegar, then copper does not turn green. And if copper turned green, then it must have been dipped in vinegar. No, because uh, copper can turn green by many factors as well. It need not necessarily be only turning green because of vinegar. So that's why option A and option B are not correct answers. I hope everyone is kind of in tandem with my understanding. Like I hope everyone understands this, how we come to the answering of this question as well. Okay then, so I'll move on to the next question. The following statements are given. So they are given three statements. This is also a similar question to our deductive logic only. So this is form of like a syllogistic logic, where you kind of connect one form of statement with another. So they are given three statements, where for statement one says CFC concentration exceeds the threshold, there will be a hole in the ozone layer. And statement 2 is saying if there is a hole in the ozone layer, then UV radiation will reach the surface. And statement 3 is saying UV radiation will cause cancer. So they are given these three statements, and then they are given a premise. The premise is saying there is an increase in CFC in the air beyond threshold. So what must hold true? So they are given four options, out of which we must choose one or more options. It's a multiple select question, I think. So we will kind of connect all the three sentences in different combinations and try to find the answer. So first, let us take the first two. Okay, let's take the singular statements itself. So since CFC is increasing, there should be a hole in the ozone layer. So option A, sorry, since there's an increase in the CFC, there is a hole in the ozone layer. So there is an increase in the CFC. Based on modus ponens, A should be correct. So there is a hole in the ozone layer, should be correct. And if there is a hole in the ozone layer, then a large amount of UV radiation will reach Earth's surface. So if the concentration of CFC in the air, if you combine statement 1 and 2, you will get to a statement that if the concentration of CFC exceeds the threshold, a larger amount of UV radiation will reach Earth's surface. And using this combined statement and this premise, you should come to a conclusion that a large amount of UV radiation will reach Earth's surface. But here they are given there is a very small amount of UV radiation on Earth's surface. So this option will not hold true. So this option will be wrong. And let's come to the last option. So large amount of UV radiation will cause cancer. So combining all the three statements together, we will get to a combined statement saying that if the concentration of CFC in the air exceeds a threshold, it causes cancer. And the incidence of cancer has increased. So it's a valid reasoning. So this option is also correct. And none of the statements have mentioned anything about death rate. So death rate is increased is not a valid logical reasoning. So this option will be wrong. So the correct options will be there is a hole in the ozone layer and the incidence of cancer has increased. I hope everyone can understand the kind of deductive logic that we are using to solve the problems. Basically, if you have been offered multiple statements and a premise, you must combine the statements in different combinations and then come to a conclusion. Only rule of thumb is that you must always combine statement 1 with statement 2, not statement 2 with statement 1. So concentration of CFC increasing resulting in large amount of ultraviolet radiation is a valid uh, combined statement. But larger amount of ultraviolet radiation causing CFC in the increase in CFC in the air is not a valid statement. So always combine the statements in ascending order, not in the descending order. So if none of you have any doubt, I'll go to the next question. The characteristic features of a metaphysical outlook are, I think this is a pretty easy question. So metaphysical people just believe that everything is fixed. This is kind of, this is also part of a materialistic outlook. But metaphysicists believe that everything is fixed, in opposite to scientific materialists who believe that everything is changing and then we need to study the change. So whatever belief that metaphysicists add will hold true. So the belief that everything has fixed properties will hold true. And the tendency of viewing things in isolation from their condition of existence. So this also holds true. So idea that the earth is at the center of the universe doesn't fall into any metaphysical or scientific materialism. And the understanding that everything is a process of change and evolution is a scientific materialistic outlook, not a metaphysical outlook. And Nikhil, I think you had something to say.
No, sir, you answered that. I wanted to know the second one. It is what is it called as? It is scientific materialism.
It's
Materialism.
scientific materialism, not
No.
metaphysics. Because scientific materialists only focus on flux or the change in things.
Okay.
Metaphysics don't focus on change.
Okay.
They focus
So
on the
it's like
object
two
itself.
extremes. These are two
Exactly.
extremes. So they are considering it's as it is. Meta
Yes.
means as it is, no change, and they are saying nothing is fixed. It's changing continuously. It's
Yes.
only,
Yes.
yeah. Okay. Thanks.
Yeah.
Arjun,
Yeah.
first one is okay, studying about the fixed properties. But second one, like, what is that actually? If the
So
studying
tendency
about
of
the existence, yeah.
no. So metaphysics, what they do is, so how do I explain this? So yeah, so we already know that metaphysicists kind of study the objects, not the changes. So we already know that when an object interacts with another object, it is kind of going to undergo a change. There's going to be some interaction with the following objects, and as a result of that, there's going to be a change, which is not a desirable outlook for metaphysicists. So what they kind of do is to study one particular object, they negate any form of interaction of that object with the surroundings. So the object in itself is an isolation. Each object which are to be studied is in isolation. And they are still existing, but they are in isolation. They are not interacting with any other things. That's what they mean by tendency of viewing things in isolation from their condition of existence.
Okay.
Wait, I think there's some interference. Can someone mute their mic? Okay. So I think everyone is clear with all the options as well. So these kind of twisted questions might you might get in the exam as well. So it's pretty important to think and answer before trying to go for any questions. I mean, judge. I'm not one to judge, but I think this will be 1 second. Sorry. Yes, I'm not one to judge, but I think this will be a paper which everyone can finish in a shorter amount of time. So I would encourage everyone to carefully look at all the options and answer accordingly, because uh, many times there is a chance of for the examiners to twist the questions, twist the options, and twist the answers basically, so that when you skim through the answers, it's pretty easier for you to miss vital details, key details in the answers that might cost you more marks. So take your time to read the answers, and these kind of answers, theoretical answers, can be solved in the later part as well. If you are not comfortable with mathematics, or if you are not a mathematics person, I would encourage you to actually solve the mathematics questions first and then go for the theoretical answers, because theoretical answers you can sort of sit through it, kind of think through it, and then you can come at the answers. Mathematical questions are not like that. Unless you solve it, you won't get the answer. I'll kind of move on to the next question. So yes, so here onwards we will start with the mathematics questions as well. So bioscientist only can take 6 observations for his measurement as the restriction of the lifetime of the bacteria he is working with. In this case, how can one define the confidence level? So we kind of know that for a normal distribution or the Z distribution, uh, 25, 25 observations are preferred. But he has only 6. So what he can do is he can define the confidence using T distribution. Yes, Nikhil is correct. So you can define the confidence level using T distribution. T distribution kind of accepts samples which are less than 10 in number as well. Okay. Okay then. So yeah, the actual mathematical part before we come to this thing. So we have corrected an experiment and we have corrected x and y, and x and y have their respective mean, standard deviation, and number of data points. So in this question, in this particular question, we are multiplying x and y, and then we will be getting a value and then an error bar for the product of x and y. So we just have to find a and b. So a value is pretty simple, I think. So you get a value by multiplying a and b. So a will be the mean product of the mean of 4.8 and 6.6, which will be 31.68. So many often the numerical answer type questions will be in. They will ask you to type the precision of the decimal places as well. So if you get decimal places, make sure to notice the question and then type the proper number of decimals if possible. You can round. You can always round off the decimal to another one less decimal place and then put the final answer. Is everyone clear with this question? Uh, so basically we are just multiplying two values, and for getting the mean value of the product, you just need to multiply the mean of both the independent variables x and y. Okay, I'll kind of move on to the next question then. So yeah, so we are testing a hypothesis, and then we have corrected data from two bound.
Sir, plus or minus b, that was not answered.
Oh, I mean, plus or minus b, you kind of take through the error measurement. So you'll get something around 0.01 for this value. I think I haven't.
Sir, I agree. I forgot. That's why I'm asking. So A is pretty clear. It's like
Yeah.
mean multiplied by mean.
So
But
for the
how do we
for
find B? Is what is it? SD with using SD?
no, you have to use SE, standard error. So that's where the number
Ah,
of data
so
points
SB
also come.
divided by square root n, na?
Exactly, exactly.
Okay. So it will be 0.36 divided by.
Uh, no, no, no. One second, one second. So
I forgot.
actually, what will happen is if you are multiplying two values, then you won't be
Uh-huh.
calculating the absolute error. So you'll be calculating the relative error.
Okay.
So
Okay.
what will eventually happen? I can type it in the chat box as well. So okay, instead of del, I'll put just star. So star z by z is equal to star x by x multiplied by, okay, or I'll put dollar. Sorry, into dollar. So you'll be using this formula. So
Okay.
yeah, so you'll be kind of equating the relative error between x and y to calculate the relative error of z, and then you already know z value, delta x x value, delta y and y value. Delta
Mm-hmm.
x will just be 0.36 divided by root of 36, and delta y will be 0.28 divided by the root of 49. So it will be
So,
0.04 and 0.06. You'll be
okay.
using it as delta x and delta y. X and y you already know from the mean values 4.8 and 6.6. And z value you already calculated it to be 31.68.
Okay. Okay. Clear.
Oh, okay, I'll kind of.
Sir, can you explain one more time?
Yes, yes, okay. I'll kind of take the pen as well. Okay. So this will be the relative errors formula. So your delta z by z will be equal to delta x by x into delta y by y. So where delta z, delta x and delta y are the standard errors, not the standard deviations. And this thing you should keep in mind, equally important. So delta x will be calculated by standard deviation 0.36. So standard error, you know already what's the formula. Standard error is the standard deviation divided by root of n, where n is the number of observations. So it will be 0.3 0.36 divided by root of 36 into 0.28 divided by root of 49. So this will be easy, and delta z we need to calculate. Denominator we already know, it's 31.68. So finally you will get delta z around. So to find delta z, what you will do is you will kind of transpose this 31.68 to the other side. So it will be 31.68 into 0.06 into 0.04. So that will be the answer, and that will
Okay, sir.
be
Clear. Thank you.
yes. I'll just get a scientific calculator as well. So 31.68 into 0.6, it will be around 0.076, and while rounding it off you will put it as 0.08. Yes. And I think the NPTEL people have already sent you the scientific calculator link as well. So it will be an online scientific calculator which will be provided along with the platform that you will be attending the exam in. So before going into the exam, kindly make sure that you are familiar with using the scientific calculator, so that you are not using it for the first time inside the exam. You can try doing simple operations like this addition, subtraction, multiplication, and then you can also try using ln, log, square root, and all those stuff. This is a kind request from my side. Kindly try using the scientific calculator then and there. Once again, I think
Sir, the delta x value is. 0 point
Delta x value is 0.36, 0.06.
0.06.
Huh. So okay, okay. This is okay. Sorry, sorry. My bad actually. So this entire value is delta x 0.36 divided by root of 36. Divide. You will also divide it by 4.8 and 6.6. Yes.
Arjun, what is that ln of x? Actually, I want some explanation of that.
So yeah, ln is basically the natural. So ln. So we have two types of logarithms. I mean, there are a lot of logarithms in nature, but the two most important logarithms that we actually use are ln x, ln of x, and log of x, log of x. So let's just say that we have a mathematical expression called okay. Let's just say x is equal to 10 power y. Are you like okay? X is equal to 10 power y. So what you will do is, so if you want to find let's just say y, it will be log of x, log of x to the base 10. So in every power, so this you already know, this is a exponential expression or a power expression. So you have a variable, and then you have a base, and then you have a power. So your base is 10, and then your power is y, and then the final variable you will calculating is x. So the power is nothing but the logarithm of the variable with the base.
For example, log of 100 to the base 10 is 2.
Exactly.
Log of 1000 to the base 10 is 3. So 10 multiplied by 10 raised to 3 is 1000. Na?
Yeah.
So,
So this is log. This is y. So y is equal to log base 10x, and similarly you will be whatever log you are using, that will be to the base 10. But instead of that, if you are using log to the base
it
e
is
is
called,
nothing but 2.732, so on and so forth. This that is a variable's number. So if you use log with the base e, then that is nothing but ln. This is the natural logarithm. Do you get it now?
Yeah, you have any example for this, like in the pipeline?
Example.
Because one of the actually in the assignment, one question came for the ln of x. I unable to answer that. Or shall we take the same example?
Yeah, we can take the same example yesterday thing, but and just give me some time to think.
Yeah. Okay.
Yeah. So you need not necessarily, so logarithmic table is not like a multiplication table per se. So in multiplication table we may be remembering numbers per se, right? But in logarithmic table, you actually need to memorize all the values. Most of the times, even mathematicians will solve logarithm only using a logarithmic table. One second.
Okay, we can do it in the last end of the session also.
Yes, 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 yes. One second. Oh, sorry, sorry. I think I mistook this 0.076. Sarita, the b value will almost be 0.0024 because you are multiplying 31.68 with standard deviation divided by mean of x, standard error divided by mean of y. So it will be around 0.002. Most probably, I think you will be asked to round it off to 3 decimal places. So the answer will be 0.002. Okay then. So I think everyone is kind of clear with this multiplication. Nikhil, example of ln of 7 point something is 2 because e power. Exactly, yeah. So basically, how you use powers. Okay then. So we'll kind of move on to the next question. We can. One second. Okay. So next question. So we are testing some hypothesis and then we are obtaining data from two populations, population A and population B. So we have a number of observations from each population and then we have mean as well as standard deviation. This should be XB bar, sorry guys. So we have certain mean and standard deviation from each population. So if the hypothesis is stated as H naught is equal to, in null hypothesis they are mentioning both the means are equal, and in alternate hypothesis they are mentioning one mean is greater than the other. They are asking us to check the test statistic for this one question. Test statistic is nothing but the Z score. So basically how you start with calculating the Z score is, you first start calculating the estimated standard error. And for estimated standard error, you have this formula where you have estimated standard error is equal to the whole square root of sigma e square by ne plus sigma c square by nc. So basically you take the you kind of get the variance. So sigma square is nothing but variance. You calculate the variance divided by n, variance divided by n, and then take the whole square root to find the n. So sigma e and sigma c you can calculate through this values. You can plug in this values 5.65, 5.65 the whole square divided by 52 plus 4.95 the whole square divided by 47, and then you add it and then you take the whole square root, you will get 1.065. And then to calculate the Z score, what you will do is you will use this formula, difference in the means divided by the estimated standard error, and if you do that you will get the Z score as 2.066. So any answer between 2.060 and 2. Since they are asking up to 3 decimal places, any answer within 2.060 and 2.068 should be a valid answer. You have any doubts, Nikhil? I think
No, sorry, sir.
that's fine. Yes. And to check if the hypothesis is validated or not, basically what you will do is you have already have the Z score as 2.066. But we know that for let's just say we want to check for 95% confidence interval. So for 95% confidence interval, we need 1.96 standard deviations. So, but already 1.96 is the Z score, that we need at least 1.96 standard deviations. But here we already have 2.066 standard deviations. So it is obviously greater than the 1.96 standard deviations. So we accept the null hypothesis. So that basically means that we do not have enough ground for rejecting the null hypothesis. Is everyone clear with this problem? So for the mathematical problem, there will be a case where you need to memorize some formulae. That is why I would also recommend. It's also recommended for you people to calculate. If you are not from a mathematical background, calculate the perform the mathematical problems first, and then go on to theory-based problems. Okay, if no one has any doubts, I'll move on to the next question. Based on the following information, answer the questions. So we are having this expression of this resistance of a wire, and then we are having the initial resistance, and then we have the coefficient of temperature, and then the temperature as well. And we have a tabular column tabulating the temperature versus the R, and using this and using the least square method, we have to find the best values of R naught and A. So we will not be going for A because alpha is much more easier thing. So in this question we will just focus on finding the best values for R naught. So uh, if we take this equation, it will kind of expand it into R is equal to R naught plus R naught into alpha t. So it kinds of, when you kind of plot R and T in x-axis and y-axis, you can see that it forms into an equation of y is equal to mx plus c, where your m is R naught into alpha, and then your c into y-axis intercept is R naught. So you have your slope m, and then you have your intercept b. So in this question they are asking us to calculate the best fit value using least square fit. We have to find the best fit for b value, and for b we have this kind of formula which we can plug in. So we have this huge formula where it has sigma xi square, sigma yi, and sigma xi into sigma xi yi, and then number of observations and sigma xi square and sigma xi the whole square. So if you kind of plug in all the, so you would have to take a pen. This would involve pen and paper in your exam, where you would need to tabulate this table in your rough sheet, and then use the calculator to find the square roots of all the values and sum them as well. So if you plug these values, you will get R naught as 14.8533. So your range of values, since they are asking in two decimal places, your range of values will be between 14.80 and 14.90. Is everyone fine with this problem?
Yeah, sir, that is okay. That is means pretty clear because you have given the.
Yeah.
So we will have to create a table, right?
Yes,
Where
yes,
we
yes.
will treat t as x and r as y, right?
Yes, T as
And
X and
then
R
we
as Y.
will one more means in that same table adjacent column for
T square, R
t
square,
square and then r square
T
and then
square,
yeah,
R square, and T into R as well, because we
yeah,
have
t
this
into
value xi
yeah,
yi
yeah.
as well, so we have to calculate T and
Uh,
R as well.
and we
yi
have
is
to
yi
yeah.
square you mostly do not need, because you only using yi here, you are not using yi
But we
square.
will need x square,
Yeah,
right?
you need x square. Yeah.
And sorry, I forgot that last one is sigma xi bracket. What is that? Raised to
Sig-
2. Yeah?
this sigma xi
Last.
the whole square.
Okay. Sigma xi the whole square.
Yeah,
Okay.
so you will just sum r
Okay.
up, and then you get a value, and then you just square that value.
Sir, I have one request actually.
Okay.
I know I'm adding means actually we will do that, but one request. Now you have given us most of the answers and also decks for it. At least for one of them, can you, while uploading deck later on
Okay.
also, can you do it in a tabular format? And maybe even I know it is very difficult to write. You are doing it by that pointer and all that. Even if it's handwritten, it's okay. But if we have that full stepwise, the way we would solve na, one or
Sure,
two
sure, sure.
problems, it would
I'll try to
be
upload
really
it as
helpful.
well.
Your
Okay.
handwritten would be perfectly fine for us. We should just understand the steps. That's so that we can
Okay.
replicate it
Sure, sure, sure.
for a
I'll I'll
practice.
I'll
For
upload
a
it.
practice. And sir, the question is actually, frankly, we find it sometimes very difficult. So we have to remember this formula, right?
Yeah. Yes,
Okay.
actually you
Where
have to remember.
will
Yeah,
there be
I
such
know it is a
questions?
tough ask. I know it is a very tough ask. Tough. It is also tough of me to ask for you, because, so I mean, honestly, I also didn't expect this much non-mathematical background people to join this course as well.
Yeah,
So
yeah.
even for me, it is kind of like, even I don't feel it in the right way to, when I am trying to solve mathematical problems for people, like, I don't find it in the right way that whether people will absolutely get it or not.
Okay, okay. No problem. So we will memorize it. There is no other alternative. But sir, just that request, ki at least one or two problems now you solve fully with
Sh-
that table and all that. One or two would be good enough. It will be really helpful, sir. Thank
Sure,
you.
sure, sure. I'll
And
try to upload the recordings and the material by Monday maximum.
okay, okay.
Uh,
Thank you, sir.
yes.
Thank you.
Yeah, and similar to R naught, we also have to find the error in R naught, for which you like we use similar bunch of formulas and using least square methods. I think after this, yeah, I think Nikhil also felt the need for remembering a lot of formulas as well. But in the end, this is what you get while calculating the error in R naught. Yes. So I'll just quickly move on to the next question as well. Yes. Okay. This kind of problems must be easy. It's pretty much dimensional analysis. So for this, you don't need to remember any formulas. This is a mathematical problem, but you don't need to remember any formulas for this. That's my whole point. So there is a formula for force, and then the force depends on certain parameters: viscosity, terminal velocity, and the radius. And we have to just find x, y, and z, and they have asked the values of x, y, and z. So for that, what we'll do is we have to solve this using dimensional analysis. So we will first list out the dimensions of all the physical quantities that are mentioned in the formula. So force we already know, it's mass acceleration. So it will be ml t power minus 2, and then your radius is just length of an object, so it will be only L, and then your velocity will be just velocity, it's meter length by time, so it will be L t power minus 1. I think you will already would have known it through 11th and 12th standard math and physics. And viscosity, it's almost the same, so it's basically force by area. So it has the almost the use of force by area per time. So it's basically m L power minus 1 t power minus 1 viscosity. So you also have this powers x, y, and z. So you just plug, and k is a dimensionless constant. It's a constant, so it's dimensionless, so it doesn't have any dimensions. So you kind of plug in all the values. F is ml t power minus 2, dimensionless, and then for viscosity is ml power minus 1 t power minus 1, the whole power x, because it's new power x. R is L, so L power y because it's R power y, and V power z, so L t power minus 1, the whole power z. So now you can, in the right hand side, you kind of combine all the m, L, and t as well. So in m you have only one quantity, so it's x. In L you have minus x plus y plus z, and then in t you have minus x minus z. So, and now once you combine all the m's, l's, and t's, you just need to compare LHS with RHS. So here we have m power 1, but here we have m power x. So x will automatically be 1. And next, if we compare it, minus x minus z, if you compare the t values, we have t power minus 2 here. Here we have t power minus x minus z. So minus x minus z should be minus 2. So x plus z should be 2. So if you plug in x from here, you will get z is equal to 1. And you already know x and z. So you just need to solve for y while you're comparing L's dimensions. So L1 is equal to minus x plus y plus z. So you know x, you know z, just plug in, you will get y is equal to 1. So final answer will be x comma y comma z has the constant value is 1. Does anyone have any doubts in this? This kind of problem is a very easy problem, I think, compared to all the other hardcore mathematical problems, least square fitting and all those things.
Sir, is that x and y, z? The same value is 1?
Yeah, all of them have 1. For this question, all the values are 1 only. X is equal to 1, y is equal to 1, z is equal to 1.
Okay.
Good. I'll move to the next problem then. Okay, this is once again a very theoretical. We are back to theoretical questions. So they have given an abstract, and then they are asking if there is any problem in this. So an abstract should be a shorter form, basically a highlight of your entire research article. So basically, an abstract should not have breaks in paragraphs, and it should have only 200 to 300 words. If we look at this abstract, it doesn't seem like it is long, so the abstract is too long is not a correct option. But abstract has paragraph break. because it should not be it should not have a paragraph break, but it has. So that's the problem. And
Sir,
we
for length, how many words was it said?
200
Mean,
to
huh?
200 to 300 words.
Okay, okay.
But
So in the
I mean, in
exam,
all the cases, you can't calculate words per se. But if you
uh-huh.
just look at an abstract, you will get to know if it is long or short. Six
Okay,
lines, seven
okay.
lines maximum.
Okay, okay.
Yeah, six
So
to nine
around
lines should do.
in the
Six.
exam, if you get this type of a question, if it's more less than
Yes.
7 lines or so, it's falling under short category.
Yes.
But
Yes.
it should have just one para,
6 to 10 lines. Yeah, 6 to 10 lines. Only one paragraph. That's
only
why.
one paragraph.
Yeah,
Okay, okay.
and you should not have any references or citations or equations. So pretty much all these options are correct only except for the first option. So abstract has paragraph break, which is wrong. Abstract has displayed equation, which is also wrong. Abstract has references, it has cited one Gambini et al. And all those things, that is also wrong. Abstract refers to an equation which appears in the body of the paper. Yes, we finally we derive equation 30, but we only get to know equation 30 if we read the paper. If a paper is logged, if it's not open access, then we can't write equations. Normally
Sir,
you can't.
can you please come
Sorry.
again? The last thing you said, if
Once
equation is
again,
what?
I'm coming back to you. Sarita, normally we can't maintain equations in abstract. You can't write, you can only have text. You can't have any quotes, any citations, any papers, any equations, or this kind of equations as well. Nikhil, coming back to your doubt. So this line, can you read this line? Finally, we derive equation 13, which quantifies the entangled state. So equation 13 is actually an equation in the main body of the paper. It's in some part of the method section or the discussion section, which we will get to know only if we start reading the paper. For example, there are some papers which are open access, some papers which are not open access. So in papers which are not open access, if you write something like this, we derive equation 13. The reader, if I come to read the paper, I can't go into the paper to find equation 13, right? Because it is logged. So
Okay,
this
okay.
kind of
So,
referring to an equation which is actually in the body of the paper should be avoided in an abstract.
okay, clear, clear.
Okay. References
So
you
he
can.
should be able to form his opinion whether to read it or not based on abstract itself.
Yes.
Okay, okay. Thank you.
References you Sarita, you cannot maintain references. So this whole context, so they are written following abstract of a paper. So there's a difference between abstract for a paper and abstract for a conference. In abstract for a conference, you can attach references because the abstract is all the data that you will be submitting for the conference. So in that case, you can submit references. But in a paper, you will already be giving another whole 6 7 pages of whatever content you have, whatever data you have. There you will be having references. So in the abstract, you should not be attaching references. Okay, I hope this point is clear. So I'll move on to the next question. In preparing slides, the 6 into 6 rules implies. So we saw in week 11 as well. If you are preparing any PowerPoint slide, any slide should not have more than 6 lines of text, and each line should not have more than 6 words. So that's the 6 into 6 rule. This is kind of self-evident. It's not like you need to think much. And next question. Yes, this thing we saw yesterday only, I think. The following amount to scientific misconduct. So anything which is not deliberate will not account into scientific misconduct. So the first option will not come into scientific misconduct. But the other 3 points, removing the data points, this will come to distortion. Conducting an experiment aiming at establishing one's personal belief, that is confirmation bias, and choosing experimental group and control group preferentially without randomization. So that is also a scientific misconduct. So all the 3 options will be wrong. B, C, D, Karthikeyan B is correct. So I think that's all the questions I have for this thing. So pretty much I have chosen a good mix of mathematical and theoretical questions from certain weeks. You might also notice that I think I might not have chosen uh, questions from week 1 and week 3, I think, because most of them just involve history and all those things. I think those things will not come, I think, will not come in the exam as well, and even if they come, it will be pretty much easier to answer. It will mostly involve definition of materialism and idealism and all those stuff.
So what will not, what is less likely to come, you said, sir?
Less likely to come is probably historical facts.
Okay, okay.
Yes.
Okay, so no, I know I cannot generalize like that, but
Yes, yes.
that's names of the scientists, what they did, and all that. That we need not very much hard remember.
Yes,
Can
yes.
I infer that?
I don't think so. Yes, you can.
Okay,
You need not to hardly remember any one of them.
okay, okay. And sir, yeah, here the last question which you are showing, I always had this small confusion here. So the answer I got is correct, that the first one, that is failing to realize that systematic error has got into it's, I failed to realize, that is okay. It's not a
Yes,
scientific
yes.
mistake.
That is not
But
deliberate per se, but
yeah, it's not deliberate, but sometimes there was also one more word na in sir's book or lecture, I don't know, carelessness or something like, he failed to realize, does it not indicate his carelessness?
I
Is
mean,
carelessness a scientific misconduct?
carelessness is not per se a scientific misconduct. See, that's a good explain. That's a see. There's always a good habit to proofread the data with your lab members and your PI as well.
Okay.
Yes, and it's also important to proofread whatever data you got with another person from not your lab, maybe the peer reviewer or all those people. So
Okay.
those peer reviewers won't have the same bias. My even see, not every human is no human is
Hmm.
perfect basically.
Hmm.
Everyone will have some form of bias towards their experiment or data. So
Correct.
it is kind of expected to not uh, take into consideration small systematic errors that came into your measurements. So
Correct.
those kind of errors can be noticed by any other outside reviewer, and if they
Hmm.
point it out, there is no wrong in this. That doesn't come in exactly under scientific misconduct. Carelessness is basically whenever a large number of data is kind of um, uh, misplaced or erroneous.
Okay.
Carelessness does not even come into, I mean, need not necessarily come into data as well. It can come in
Okay.
a lot of places. If you fail to maintain data, or if you
Mhm.
fail to maintain biological samples or human samples, that also comes under carelessness. Maybe if you fail
Okay.
to plan your experiment accordingly, when you have uh, mice samples or human samples, that comes under carelessness. So that is scientific misconduct. So basically, that you're not only you're careless, but you are also not valuing human life or any other life that you are dealing with.
Okay. Okay. Sir, and one means, I know there is no hard and fast answer for this, but approximately, can we guess, means at least a guess, what percentage will be theoretic questions and what percentage will be actual problems?
No,
Okay, okay, no.
I can't.
Okay. And sir, so that was the only request, that at least one or two problems, please solve completely, and even handwritten, that is okay, and please upload. That will be really, really helpful for those who have lost touch with numerics for some time.
Sure, sure, sure.
That will
Uh,
be really helpful.
sure,
Like making a table, then making x square. So that gives us some, reference, very good reference for us.
sure, sure. Namrata Soneb, sir, please explain the demo of online calculator for standard deviation. I think I have the online calculator with me. I'll just see if I can pull it up.
Sir, I think they have given the, in the announcement they have given this link for for doing practice of online calculator.
Yes, 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 yes. I am just trying to pull that up. Let me know if you people are able to uh, get it. I'll stop presenting the slides and I'll start presenting. Can you see the screen, everyone?
Yes, sir, we can see the calculator.
I'll
This is the
just
same calculator they have given us, na, in the link.
yes.
Okay, sir.
I just have the link to the calculator because just to get some updates about the course, I also registered in the course. That's so I have also got the scientific calculators link. Okay, so you want a demo of online calculator for standard deviation. Okay, so standard deviation, I mean, there's no formula or operator here for standard deviation. So maybe what we can do is we can calculate some standard errors, maybe. So you guys can pay. So what we can do is we already have we have that 0.36 problem, right? So we have standard deviation of 0.36, and then we have number of observations as 36. So we can try to calculate the standard deviation. I'll just write it in the chat box as well. Standard deviation is equal to 0.36, and then number of observations is 36. So with this parameters, we have to find the standard error. So what we can do is we can put 0.36 um, divided by yes divided by square root of no okay
Sir, I think you can edit there by clicking in the top box.
yeah.
That is possible.
36 yes. So yeah. Oh, how to calculate standard deviation? Okay, that's pretty much simple. So for calculating standard deviation, all you need to have is mean.
Uh, yes, sir. Sir, just two, three queries about this because I have hardly used scientific calculator online.
Okay.
Used to use it during my
Okay, okay,
BE.
okay. No problems actually. So we can actually calculate from first everything, mean, standard deviation, everything. So just I'll just put a set of values here for everyone to so just that I can calculate the mean and standard deviation. We have 36, 89, 54, 12, 43. So we have five values here. So we'll calculate the mean and standard deviation for all these values using this standard scientific calculator. So what we can do is can I use the keyboard? No, I can use the keyboard, right? So I'll put 36 plus 89 plus 54 plus 12 plus 43. Okay. So if I sum all this, I'll get 234. You can copy this value maybe, and then you can put, or you can note down this value as well. Or what you can do is you have 234, you can just give 2 divided by number of observations. We have 5 observations, right? So you can just give 5 and then press equal to find 46.8. So you will always have a rough sheet with you. So just note down this value. Mean is equal to 46.8. So now you have to
Sir,
find.
how were you able to calculate? Because I'm not able to select the value. The way you had selected now, let's say 46.8. Even if I double click in that, I am not able to select.
How will you select that value as in I don't get it.
No, no, you selected na just now. You I could see on your screen that you had selected the value on the second line. For example, 46.8.
No, I haven't selected the value. So do you mean now? Now I
Uh-huh. If you double click, it is possible or no?
no, it's not possible.
Okay.
Yes. So 46.8. So we need so standard deviation is basically the deviation of each values from the mean. So standard I will write the standard deviation for once again. I'm in a TA session. Yes. Okay. So standard deviation formula we all already know. So it's the okay. I'll just read the whole formula. standard deviation is equal to the whole square root of uh, x minus x star, the whole square divided by n. Yeah, I hope you all can see the chat box as well, the whatever formulas I'm putting in.
Yes, yes,
Yeah.
we can.
So I just written x star as mean here. So yes. So x star is mean. So standard deviation is calculated by, so you take x minus x star for each of the values, you square it up, and then divide it by you like sum all of them up, and then you square. Okay. Okay, there should be a sigma here as well. So it's x minus x star the whole square sigma divided by n. So sigma is just summation. So we will try to do exactly that. So 46.8, I hope everyone has like noted it down in the chat box. I have already written that in the chat box as well. Now we need the values, right? Okay. So we will clear the calculator screen once again, just for safety. So uh, we'll open brackets first. So 36 minus
46.
46.8. Okay. 36 minus 46.8. Whole square is here, I think. No, 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 no. Sorry. 36 minus 46.8, close bracket, and then whole square. Where is it? Whole square. Whole square. So we have got 36 minus 46.8 the whole square plus open brackets once again. Next value is 89. 89 minus 46.8 the whole square. So we are getting 36 minus 46.8 the whole square, and 89 minus 46.8 the whole square, plus you keep on doing this for all the other three values as well. 54
So
minus, sorry,
repeated the deviation, standard deviations values, and scientifical.
sorry, I can't hear you.
So the from starting the standard deviation calculation.
You want me to repeat it?
Yes.
Cool, cool. Okay, so can you first see the all the five observations and the mean?
Yes.
Cool, cool. So what I'm doing is I am summing up all the difference of the values from the mean and then squaring it up. So basically what I'm doing is I'll open brackets and then 36. 36 is the first value, 46.8 is the mean, and then close the brackets and then whole square. You get this one value. If you want, if you're comfortable with doing long calculations, you can join it up all together, or you can just for simplicity purposes I'll just type it down here as well. 116.64 is the first value, x minus x bar the whole square.
So just a wait. I'm calculating.
Okay.
Sir, okay.
116.64.
Yeah.
So after that what I'll do is you have to sum all of this x minus x bar the whole square for all the values. So plus, again open the brackets, 89 minus 46.8, close the
Sir, the
bracket.
sir 10.8.
Yeah, minus 10.8 is 36 minus 46.8. So you are squaring that value.
Okay.
Yeah, and 89 minus 46.8 is 42.2. So you are squaring that value once again. So you'll get square of 42.2 here.
42.2 is. So can you do it first thoda slowly?
Sorry.
Can you do to thoda slowly?
Slowly. Okay, I mean, I'll. Okay, so you have already noted down the first value. That you have no problem with the first value, right?
Yes.
116.64. So we will do it for 89. We'll start with 89. So 89 minus 46.8, 46.8, close the bracket. I'm closing the bracket because I need to put whole square for it. Close the bracket and then put x square button square whole square. So if you put the whole square, you will get 1780.84. I'll put the value here as well. Are you clear with this now?
Sir, 1 second. I'm doing it.
Sure, sure.
Hello, sir.
Ah, yeah, Damodir, go ahead.
Sir, how much we have to take the sigma?
Sorry?
How much we have to take the sigma?
So sigma is the summation, right? So right now for Dakshata's convenience, I'm not taking, I mean, I'm not summing it continuously. Rather, I'm calculating the x minus sigma, sorry, x minus x bar the whole square individually, and then finally I'm noting down all the values. So I'll add it up all of them, divide it by
And
5,
divided by
and then
5.
take the square root.
Okay, okay. Yes, sir.
Sir, the
Yes,
square, my answer not is right. That is 1780.
1780 is only the correct answer, right?
But no, is not mine.
What is your answer?
1536.
Did you give 89 minus 46.8?
Yes.
Uh, did you put whole square for all of them, or did you put only square for 46.8?
The bracket square is 86 minus 46.8
89.
bracket complete. Then x square.
89 minus 46.8 and then whole square.
Yes.
Okay. Are you getting 42.2?
No.
Then you must
I'll
have
just check
typed.
it.
Then you must have typed something wrong.
I'll do it for 1 second or.
I'll in the meantime I will go with the other calculations as well because I think we are running out of time.
So do it for 1 second.
Okay. So I'm opening brackets. Can you see the open bracket? Then I'm typing 89 and then minus 46.8, right? 46.8, and then I'm closing the brackets to finalize the operation. So we have 89 minus 46.8, which gives you 42.2. Are you getting it till here?
Yes, sir.
42.2, you are getting it here. Press this
No.
button now. Are you getting
Yes,
1780.84?
sir.
Huh. Then I think you did something wrong in clicking the buttons.
Yes, sir. Some value is wrong.
Okay. Yes. But you basically get the idea of it. So you don't need to. I'll just go through fastly how to do all the other calculations as well.
Okay, sir. Thank you.
Yes. So next value is 54 minus 46.8, and if you do whole square, it will be 51.84. I'll just write it down here. Either you can do note these values one by one, or you can just uh, continuously put plus and plus and plus and then add all of them as well. Yes. So next is 12 minus 46, 46.8 whole square 1211.04, and then finally 43. 43 minus 46.8 is equal to minus 3.8 whole square will give you 14.44. So now you have five different values, and what you have to do is you have to take a sum of all of them. So clear it. So you have 116.64 plus 1780.84 plus 51.84 plus 1211.04 plus 14.44. 14.44. If you add all this, you'll get 3174.8. You have to, since we have 5 observations, you have to divide all of this by 5, and then you'll get 634.96. And then after this, you have to take the square root of this. So where's the square root here? Wait, what? Oh, square root is here. So square root is here. So 634.96, if you put square root, you are going to get the standard deviation as 1984. Depending on the number of decimal precisions they are asking for, you can either round it off to 1 decimal place or 2 decimal place or 3 decimal places. Is everyone clear with this? So mean, standard deviation, calculating mean and standard deviation using scientific calculator. You can, I think you have 2 more weeks for the exam. You can just try practicing using the scientific calculator so that you will use it much more faster.
Sir, just one more question. I hope you have seen the book, right, sir, of this, not
No,
the day.
I'm not
Okay.
seeing the book. I'm seeing
Okay.
the lectures.
So one doubt is that
Yes.
x square is equal to whole square?
Sorry.
Is that x square is equal to whole square?
Yes. X minus x bar the whole square.
Thank you, sir.
Yes. That's the standard deviation formula.
In the button x square is there, no?
Yes.
That one we use for whole square.
If you that is the thing. So if you have brackets, if you are
Yeah.
enclosing any expression within brackets, you are
Yes.
going to put whole square. So whatever value is here, that's
Yeah.
going to get squared. But if I
Yes.
have 2 values, let's just say that one second. I'll just clear the screen. 33
Yeah.
minus 65. If I put whole square here, it will come as 33 minus square root of 65 only. It will not come as whole square. Whatever
Okay.
value is here, that will only get squared.
Okay.
Yes.
Okay. Yes.
So if you want square for whole expression, you should put brackets and then put square. So it will be whole square.
So,
Yes.
where is the square root only
Here.
used, and there is a two square root?
Here. This is square root.
How to identify it?
No, square root will not have any number outside the root. So that is square root. This is cube root, not square root. Mostly you won't be needing cube root for your calculations. This is cube. So similar to how we have square and cube, you have square root here and then cube root here. This is the uh, arbitrary root. So depending on the number of y, the yth root of x, you will basically get the yth root of x. So y is equal to 2, you'll get the square root. Y is equal to 3, you'll get the cube root. 4 is equal to quadratic root. 5 fifth root, 6th root, and so on and so forth. So similar to how you get the 5th power, 6th power of 7th power of x here. So I think everyone is clear with the using the scientific calculator as well. So any other doubts? I'll stop presenting this slide. Sarita, you can go ahead.
Sir, our question is there, no, sir? Our question, previous screen.
Sorry.
Previous screen.
Yes. Previous question.
Previous question. R.
resistance table.
Oh, okay, 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 okay,
R.
okay.
Previous.
Yes.
Yeah, just please explain this one once, sir.
So yeah, so this problem is related to the least squares fitting problem in your week 9 or week 10 of lectures. I'm not sure now. So basically, what you have is, so they have given this formula. So R is equal to R naught into 1 plus alpha t. So your job is to expand this formula. So you'll get R is equal to R naught plus R naught into alpha into t. So, and they have given, so whatever relationship is, this relationship depends on different values of t and r, and r naught and alpha are constants. So relationship depends on t and r, and then r naught and alpha are constants, which you have to find out using least squares fitting method. So these are variables, and in the question itself they have mentioned that for different values of t you get different values of r. So you can plot it across a graph and then get different points. And then if you observe this equation, r is equal to r naught plus alpha into t, you will get the equation. Wait, I'll just write using laser pointer as well. So r is equal to r naught alpha t plus r naught. So this equation kind of resembles the linear equations line. Y is equal to mx plus b, where m is the, so if you plot two variables in a graph across a linear fitting line, then m will be the slope and b will be the y intercept. So this equation kind of resembles y is equal to mx plus b. So which will be m and b here?
R
B
naught is
means R not only, no?
B is r naught, but what is
Uh,
m here?
alpha R naught.
Yes, I mean, yeah, Nikhil, like we can
Okay.
let them answer as well. Yes, sorry. Sarita, can you get the question right now? Can you identify which one is M and which one is B here? So
yes, sir, yes, sir.
we have an equation with us. We have also the linear fitting equation with us, which is y is equal to mx plus b. So if we just compare both the equations, we come to know that b is equal to r naught and m is r naught into alpha.
Okay, 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 sir.
Yes. So this R naught into alpha is for another problem. We have to, if we have to find alpha, then we can use this R naught into alpha. But for this question, we just need to find R naught, which is here, and R naught is B. And for calculating B using the least squares fitting problem, we have this formula here. It involves a lot of squaring, summing, and all those stuff. So using, we already know that here x is t and y is r. So here t, this is x, and r is equal to y. So depending on this formula, you would want to obtain the square values of all the x values and product of all the xy values and sum all of them. Get the sum of all the x's, get the sum of all the y, get the sum of all the x into y, and get the sum of all the x squares. And then you just need to plug them into this formula, then you will get r naught's value. Are you getting the question now? Like, are you getting how to solve the question now?
Yes, sir, yes, sir.
Okay. Any other doubts? I'll leave the room open till 1:35. uh, we'll see if people have any doubts. Else, we can conclude the session as well. Yeah, yeah, sure. Thank you. Like, I am actually pretty sorry for today that I have to postpone the session 1 hour late. So I think if people have no doubts, then I think April 27th is your exam. So I wish you all the best for your exams, and thank you for all your interactive sessions for 13 weeks. Uh, yes, I mean 12 weeks, but 13 sessions. It was a good 13, good 13 sessions. It was a learning session for me as well. Even I got to learn equally with you people as well how to do things, and even with respect to teaching, it was a good teaching experience for me. So without you guys, it wouldn't be possible. So thank you first of all. I will upload this. I like Nikhil also suggested to upload, modify some content and add some tabular formats as well. So I'll try to do all the changes by this weekend, and I'll try to upload this PPT file as well as the uh, recorded video in the YouTube channel. And I think recorded with 2 or 3 fully solved problems. Yes, sure, sure. Yes, and this recorded sessions, as usual, if people don't know already, it will be available in the problem solving assessment tab in the NPTEL course section. So you can always go there and access the videos whenever you want. And if you want to later access it for your future reference, you can always bookmark those videos. It will always be posted in my YouTube channel, in that YouTube channel of mine. So you can bookmark it and save it whenever you want, so that you can go there and visit it whenever you want. I am not sure about the drive link because it might be stopped sharing, but yes, YouTube channel, the YouTube channel will be still on. It will be the videos will be posted even after the course has ended. So feel free to go to the videos if you have doubts later in the session, and then clarify your doubts there as well. And till the exam, if you do have any doubts for the next 2 weeks, I will be available in email as well as in the Google groups. So feel free to post any doubts. Google groups, I'll try to reply as fast as possible as well before the exams. So if none of you have any doubts, I'll conclude the session. Once again, thank you everyone. Um, See you probably in another repetition of this course or any other course. Thank you. Yes, yes, I'll send the recording. I'll send the recording in the NPTEL tab. Yes.